The first thing I want to do is I want to look at this. What is this, you think? Yeah, this is actually hello, and it is in many, many, many different languages. And the only reason that you could maybe know that is you might know hola, which is up here. And then you can see one that's obviously very similar to English right there in the center above bonjour. But the fact is that in order to read these, you would have to learn the language, right? In order to read these, you would have to know the language. And that's what math is all about. So with math, we don't necessarily write it out like this. We write it out with some different types of notation. The first notation we're going to talk about is the notation of the word variable, okay? And so math, I like to say, is its own foreign language, all right? It is a universal language, meaning your numbers can go to anywhere in the world and your numbers will be the same pretty much, right? And so when we talk about variables, variable is just a symbol used to represent any element of a given set of numbers, okay? Now, we use A, B, and C. When you get up to like calculus, we actually use Greek letters in calculus. But variables can be anything that represents this element, all right? Very often in standardized tests, they love to throw at you like triangles and squares and everything else, and you have to figure out what number it represents. That is just a variable. They have just done it in geometric shape form instead of X, Y, or Z, okay? And so a variable is just a symbol used to represent a set of numbers. The other thing that you'll see in algebraic expressions is a constant. Now, if a variable varies, a constant does not. And so a constant is just a fixed number. So if you have a fixed number that does not have a variable next to it, it is called a constant. An algebraic expression then is an expression containing numbers, variables, and operational signs. By operational signs, they mean plus, minus, multiplication, division, exponents, things like that. So algebraic expressions are mathematical expressions that combine numbers, variables, and operational signs. Numbers, variables, and operational signs. So we're not technically solving for any variables yet. We will be evaluating algebraic expressions. When they say the word evaluate, what they really want you to do is they want to substitute in numbers for the variables that you see, and then you are really just doing order of operations to come up with the answer, okay? So evaluate just means plug in the variables with numbers and then solve it using order of operations. That's what evaluate means. Substitute your values for your variables and then simplify it. So let's look at an example of this. At the top of page 47 is your first example. They want us to evaluate the expression x plus 9 for this domain. Now this is a word that just means your input values, okay? So domain just means here's the list of input values that I want you to do. And so if I wanted to evaluate this, I would actually take each one of these inputs and I would plug it in for the x. So if I wanted to evaluate this at -5, then I would say -5 plus 9, which is -4. If I wanted to evaluate at 1/2, then I would say 1/2 plus 9, which is just 9.5. And so that's what you're doing when you are evaluating. You are simply plugging in something for the variable, and then you are solving for it. And so you can see that you can evaluate at any number, plug it in, and solve. And so once you have done that, the values that you just found, those are called the range. So the domain are the values that you put into the problem, and the range are the values that you get out of it once you solve. And these are two terms that you're going to need to know. Domain is your input, and range then is your output. All right. Domain is your input. Those are the values you plug in. Range is your output. Those are the values you get out once you solve them. And right here that they gave us, this particular expression had one variable and it had one constant. My variable was x. All right, and so if I look here, I had one variable. So if I wanted to identify the variable, I would say my variable was X. I also had one constant. My constant was 9. Constant is the number that doesn't change. It's just a fixed number. And so my variable here was X and my constant here was 9. Domain is the number of inputs. Range is what I found when I plugged in for my variable and solved. All right, let's look at example 2. If C represents the cost of one pencil in cents, the algebraic expression 10 times C represents the cost of 10 pencils. All right, so if I have a cost of a pencil and I have 10 times that cost, I have just told you how much 10 pencils cost. That makes sense, right? If the domain of C is 5, 10, and 17, evaluate the expression for each member of the domain. So they have told me that my expression here is 10 times C. And then they have said the domain is 5, 10, and 17. So they want me to find out when C is 5, when C is 10, and when C is 17. So I'm going to do that. 10 times 5, what is that? 50. 10 times 10. And then 10 times 17. Right. Now, what does this represent? Well, we know it's my range, right? We know it's my range. But in logical terms, they gave me 5, 10, and 17. What did that represent actually, like physically in the world? What did 5, 10, and 17 represent? The cost of one pencil. They told me how many pencils, right? 10 pencils. C represents the cost. If I plugged in something for C, then I was plugging in the cost in cents for the pencils. So that means for this first example, my pencils cost how much? 5 cents, right? How much did they cost here? 10 cents. How much do they cost here? There we go. And so when you start introducing word problems, it's very, very important that you know what your words represent and what your variables represent. All right? And so very often when I have you set up word problems, you'll see me out to the side and I will say C equals cents. And you can even say cents for one pencil. Whatever you have to do to remind yourself what that is. Because then when you solve for it, it will tell you if you're logical. All right? And I like to give the example. I was doing an algebra problem and I gave the problem and I wanted them to give me the miles per hour of the boat. Okay? And the answer that I got was over 500 miles an hour when they gave this test back to me. Now, what were they solving for? How fast a boat was going. Has anyone ever been in a boat? Probably not at 500 miles an hour, right? I mean, you're airborne at that point, okay? And so the logic should have been, okay, I did something wrong because I got 540 miles per hour, but they didn't go back and think about what they were solving for. And so when you set up these expressions, it's really important that you know what your variables represent. If I ask for how many hours it took to travel, I have gotten negative numbers. What's the problem with negative numbers when I ask for hours? We are not time travelers. We do not go back in time, right? And so the logic should kick in and say, oh, I was finding hours and I got a negative number. I probably did something wrong, okay? And so setting up these variables is very important that you remember what the variable represents, because if not, then you might get to the end and you'll say, oh, 17 pencils, and you're wrong. You didn't solve for 17 pencils. You actually, 17 represented the cost. And so 170 represented the cost of 10 pencils, all right, at 17 cents a piece. And so it's very important that you understand the logic and how you set these up and what the variables represent. All right, let's go over these. Number 2, what are your variables there? Yeah, you have A and B. Those are your variables. What's your constant? 3. All right, so your variables are your A and B. Your constant is going to be your C. All right, they want us to evaluate. The first thing they wanted to evaluate was when y is -4. What is -4 plus 6? -2, or +2, not negative. Helps to write it correctly. What about y equals +1? There we go. What about when y is 3? And then what about when y is 8? There we go. So if it does tell you to, so it just said evaluate each member of the domain. If it said find the range, then you would want to write it in set notation from least to greatest. So if it did tell you, if it had added find the range, something like that for instructions, then this would be your answer. So if you go back to page 47, they give some common terms. Now, these are going to be really, really important as we start building these algebraic expressions, as we start building algebraic equations, and then we start doing word problems. All right, and so these are just common words that they use. For addition, sum, they actually straight up say add them, or it can say you have 3 more than, something like that, or something increased. Okay, so all of those words will mean addition when you hear them. Okay, subtraction. Difference, that's a term for it. It may actually say subtract. It may say you have 3 less than. That means whatever it was, subtracting 3. Or they can say something decreased. The amount of money they had decreased by $5. That means you subtract $5. Diminished, that also means that it was reduced by a certain amount. All of those mean subtraction. For multiplication, product is your term that you use. It may say times or multiply. One that they use a lot is twice or 3 times as many. Of. So if it is the word of, it will always mean multiplication. So you have 3/4 of $1. That means 3/4 times $1. If you have 3/4 of an amount, that means multiplying. And then doubled. They could say something doubled or tripled. That just means you multiply by 2 or multiply by 3. And so those words will mean multiplication. Division. Quotient is the proper term for it. They may actually say divided by half. All right? If they say half of something, you are dividing it in half or you are multiplying by 1/2. And so you have to think about that. Per. Sometimes they'll do this when they are saying that it's this per can be a little tricky because that could be multiplication or division. They put it in division here, but you could say the price per gallon, and that would actually mean multiplication. But if it is like a total number of pages and how much was it per person, then they're wanting you to divide. So pay attention to that one and see what they're actually asking. Average. When you find an average, you're going to divide. All right, you're actually going to add something up and then divide by the total. And so average may indicate that you are doing a couple of operations there as well. So let's look at the first thing we're going to do. We're just going to translate. Translate these. They want you to go from words to algebraic expressions. And so when you see the word a number, that is going to be where you're going to put a variable. Okay? So when you see the word a number, that is a variable. So let's look at this first one. You see the sum of a number and 4. And so if you want the sum of a number and 4, sum means what? Addition, subtraction, multiplication, or division? It means addition. So x plus 4 is how we would write that algebraically. Let's look at B. The difference between a number and 5. What is difference? It is subtraction. So for B, I would say x minus 5. And you can use any variable. You don't have to use x. I will say be very careful of certain variables. If you use Z, you need to be very careful about how you write your Z. I always write my Z and put a little slash through it because it can very easily look like a 2, okay? Very easily look like a 2. T is very often used for time. I'm very careful about how I write my T's. You'll notice that I did that and I did not do this. Why wouldn't I do that? Looks like an addition sign, and instead of using a variable, you'll add some numbers up and you'll get it wrong, all right? I don't ever use O. Why do you think I don't use O? Looks like a 0, okay? And so as you're doing your variables, you need to be cognitive of what you're writing so that not only can I understand what your variable you use, but more importantly, when you're solving it, I have had people write down the variable and then think it's a number and then start solving with a number because they didn't realize it was a variable later on in their problem. So be very careful as you're writing some of these. I typically use X if I'm just using it. In a word problem, I'll very often link it to what it stands for. So, and later on we're going to do it with hot dogs and hamburgers. So maybe a D for the hot dog and an H for the hamburger. And then I define it over to the right what it stood for, okay, when it's a word problem type thing. So just when you're thinking about what you're writing, you may want to do that one. All right, let's look at some other of these. 1/3 of a number. So we have 1/3 of a number. How would I write that? What does of typically mean here? Right, so I would say 1/3, and you can just say X, or you can say 1/3 times X, or you can use your parentheses if you want to. I would typically write it like this. If it is the number butted right up next to a variable, it means multiplication. You don't need any other operation symbol in there, okay? So 1/3 of X, you can just write 1/3 X, and all of it means multiplication. All right, let's look at D. A number divided by 6. Well, this is very simple. They actually told us the operation that they wanted. They want division. You do have to list it in order. So this means a number divided by 6, not the other way around. It does not mean 6 divided by a number. It can be written like that, or it can be written like a fraction. All right, let's look at E. The sum of 3 and 8 times a number. The sum of 3 and 8 times a number. I have two different operations here, okay? They are adding 3 and 8 times the number. How do I write 8 times the number? 8 times any, yeah, your variable, whatever your variable is. The sum of 3 and 8 times the number. All right. Let's look at 8. 8 less than 3 times the number. All right, this is the one that people almost always flip, okay? People will invariably say 8 minus something here, okay? But if I said I have 8 less dollars than Jared has, you would not take my dollars and subtract 8 from it. You would take Jared's dollars and subtract 8 from it, right? So if I say I have 8 less than something, you are actually subtracting the beginning part from the ending part that they have said. So they want 8 less than 3 times a number. They actually want us to take the 3 times a number and subtract the 8, not the other way around. And this one, when they use less than, is almost always the one that people flip. They always flip it. Next one. The quotient of the difference of a number and 8, and then they actually put a comma here. So this tells you that this is where they want the quotient line. So they were very specific here. And twice the number. So the quotient of the difference of a number and 8 and twice the number. So they have been a little more specific than they even were in this E that we just had the question about. So in this E, they just kind of ran it all together. The sum of 3 and 8 times the number. When it's like that, you are going to assume order of operations, that the 8 times the number is grouped together and the sum is going to be separated. But in this case, they said the quotient of the difference of a number and 8, that's going to be my numerator. Twice the number, that's going to be my denominator. Okay? And so when we write this one is a little bit different than the one above it. The quotient piece is talking about the difference of a number of 8, twice the number. So we would say The difference of a number and 8, that's going to be just 8 subtracted from some number. And then the quotient here is twice that same number. You could also write it x minus 8 divided by 2x. If I write it out, I must put parentheses here. Remember, when you do the fraction line, it automatically groups it. When you don't, then you have to put parentheses to force it to group it. Okay? And then let's look at h, the last one here. The opposite of the reciprocal of the square of a number. Okay? The opposite of the reciprocal of the square of a number. Let's break this one down. All right? So, that one's actually G. Square of a number. How do I write that? How do I write the square of a number? Yeah, x to the second power. They want the opposite of the reciprocal. How would I do the reciprocal of this? Reciprocal, what do I do with reciprocal? That's flip, right? How do I flip a number? That's opposite. How do I flip a number? If it's just 3, how do I get the reciprocal or the flip of 3? 1/3. All right, we put a 1 on top of it. So reciprocal, you flip it, and if it's just a number, you're going to put a 1 on top of it. So the reciprocal here would be 1 over x squared. And then they want the opposite. Opposite's where you change the sign. Yep, so negative. Negative 1 over x squared. So as you look at this, opposite is going to change the sign. That's going to be negative. Reciprocal, that's going to flip it. What are we flipping? We're flipping the square of a number. And remember, when you just have a number and you need to flip it, you just put a 1 on top of it. Okay? You just put a 1 on top of it. Questions on that one? So let's try some of these. Page 48, number 14 and 18. All right, the first one, a number decreased by 17. Decreased is subtraction. The sum of twice a number and 6. Twice a number is 2x. Sum is addition, so, and they used n, 2n plus 6. 2n plus 6. All right, so they jump right into a little bit more difficult. Write an expression for the sum of 3 consecutive integers. So first of all, we learned what integers are. What are integers? Yeah, whole numbers and their opposites. So 0, 1, 2, 3, 4, and then negative 1, negative 2, negative 3, negative 4, okay? So basically what you see on the indicators on a number line, 1, 2, 3, 4, and then the left side, negative 1, negative 2, negative 3, negative 4, all right? So then what does the term consecutive mean? Consecutive. In order, right? So if I wanted consecutive numbers, I would say 1, 2, 3. I wouldn't say 5, 3, 7, 9. Like, that's not consecutive anything, okay? I could say consecutive odd integers. What do you think that would mean? 1, 3, 5, 7, 9. Consecutive even, 2, 4, 6, 8, okay? Consecutive just means in order, all right? So they didn't tell me where to start. They didn't say start at 1, right? They just said write an expression for the sum of 3, any 3 consecutive integers. So I have to start with my first integer. Do I know my first integer here? Did they tell me my first integer? No. So if I don't know the integer, I am going to list a variable, right? That is my first integer. Does everybody see that? So then if x is my first integer, how do I get from one integer to the next? 5 to 6 to 7 to 8. How do you do that? What are you doing to get from 5 to 6, and then from 6 to 7, and then from 7 to 8? You're adding 1. So if this is my first integer, my next integer will be x plus 1, right? So then what will be my third integer? If my second one is x plus 1, what will that one be? X plus 2. So this is my first integer, this is my second integer, and this is my third integer, all right? And they want the sum of those numbers. So how would I give them the sum of that? What do I do? What does sum mean? Add. So I want x plus my second integer plus my third integer. Now, if we were doing this in a word problem, we would combine like terms and all sorts of things. But just setting it up, This is the sum of my first, second, and third integer. I don't know what they are. They haven't told me, but I set up this algebraic expression for that. If they had said sum of the odd integers, I would say, how do I get from one odd integer to the next? How do I get from 3 to 5, and from 5 to 7, and from 7 to 9? Yes?
Couldn't you just write that next to...
If I wanted odd, they're 2 apart. So it would be x plus 2, x plus 4. If I wanted even, they're also 2 apart. X plus 2, x plus 4. All right? So you have to pay attention to the words they're giving you. Consecutive means in order. Integers is something we've already learned. All right? Let's look at another example. This is actually from some of the classwork exercises. Joy's keyboarding speed is if Joy types twice as fast as Monique. Do I know how fast either one of them type? No. I do not know. But I do know they want Joy, they're saying she is twice as fast as Monique. So I am going to have to set up a variable for Monique, right? We don't know how fast she types. We'll just make it M. All right, so we'll just say her variable is M. How would I write twice as fast? 2 times M. All right, 2 times M. Yeah, and we'll do equations. These are just expressions. So if it said if it was an equation, you would have an equal sign in it. But for expressions, you don't need an equal sign. All right, let's look at the first one. The amount that Evelyn makes the week she gives X haircuts at $25 each and Y perms at $90 each. They gave you your variables. What does each mean? What operation is this going to be? Addition, subtraction, multiplication, division. Multiplication, right? If I say these shirts are $5 each and you buy 6 of them, how do you find your total cost? Well, you definitely multiply. Yeah, so you would say 25 times X, that's how much she would make with haircuts. And 90 times Y, that's how much she will make with the perms. How do I find out what she makes all together? I'm going to add them. All right. Reciprocal of the, why is it jumping around? Of the absolute value of the number. All right. Reciprocal of the absolute value. Really quickly, you should have gotten 1 over the absolute value of X. And then if you did the dollars for the hot dogs, 6D plus 12H.